Hi everyone. During the next 12 minutes, I will be talking on the impact of different sources of precipitation data on urban rainfall runoff predictions. These are results which my colleagues and I from Eawag have been working on. 2 years ago, I was working in an industry company, and I was given the task to calibrate an urban drainage model. The problem we faced, we didn't have any rainfall measurement on that site. What we ended up doing was using a rain gauge measurement operated by the local wastewater treatment plant 30 kilometers away. So if you look at this picture, you can imagine that the variability of such a storm can't be captured by such a rain gauge, especially if it's far away. The question I was asking myself, if this input is reasonable and if we can somehow quantify this effect of different rainfall input data into an urban drainage model. During another project, I met Jörg Rickermann from Eawag, and we started talking, and he told me that he was measuring already in a certain area. We now look at the catchment of Adliswil. It's next to the city of Zurich. We're in the exquisite position to have 6 rain gauge measurements installed in this small catchment, which is only 1 kilometer by 3 kilometers. We have radar measurements provided as a product from Meteo Swiss, and we have the data of 19 commercial microwave link stations around this area. What we also have is a calibrated model, a swim model of this catchment, and we also have a flow measurement at the outlet of the wastewater treatment plant. So now we have to think about how we would compare these different rainfall products. We came up by doing a sensitivity analysis. What we did is using the rain gauge measurements. We had to skip one because it was the one operated by the local wastewater treatment plant where the data was not compatible with the other ones. We did the inverse distance weighting for the spatial distribution and called this scenario our ground truth. Then we compared it to a scenario where the data is coming from microwave links. We ended up using 12 of them, did processing as already Lotte has described with the baseline removal, wet antenna attenuation correction, and a spatial interpolation, which was also based on inverse distance weighting in a modified form, and used it as our microwave links base scenario. The next one was also consisting of microwave link data, but adjusted to a rain gauge. A fourth scenario was using the radar data which we had available, which at that time consisted of the information of the 3 radar installed in Switzerland. It was back in 2013. So the workflow was given. We had to do some data handling to get all the data into the right format, do all the pre-processing of the different scenarios, event selection based on the measured flow and the rain gauge information. Then we had to do a time integration that we have the comparable step sizes, the spatial interpolation, and then the spatial interpolation consisted of pointing all the information to the subcatchment which were modeled in the SWIM. Feeding that to the SWIM and looking at the output. I first want to show you or an additional remark. Our coding is available on the GitHub account if you're interested in and if you have additional remarks to include. The first thing I want to show you is that when we already looked at the rainfall data itself, so comparing the rain fields with the rain gauge measurement scenario, our ground truth compared to the microwave links, only using the microwave link data, we had a heavy underfit. So we ended up, or if we compare that to the adjusted scenario, you already see within the rain field a higher correlation of the two measurements. After the SWIM simulation, we had for a certain event pictures like this. So in purple, you see the rain gauge measurement, our ground truth, which translated, so here's the rain, which translated into this flow curve. And you see what I want to point out for the radar, especially the blue line, we sometimes heavily underestimate the flow and sometimes overestimate the flow. The microwave links seems to follow a little bit better the ground truth. Another example where you can see that the radar is underestimating, the microwave links without adjusting is also underestimating, and we have a higher correlation between rain gauge and adjusted microwave link scenario. In total, this ended up we had a time span or a period of measurement data of around half a year. We could select 35 events out of that, including convective and just other storms. The total rainfall sum for the base scenario was around 300 millimeters. In total, we underestimated for all the other ones. The runoff numbers were behavingly accordingly. So the thing we compared was a ratio between runoff and rainfall to see if the model, the SWIM model in between, has any big impact. So what I want to point out is that we have to adjust the microwave links that we end up with a reasonable result. What I wanted to discuss is the point I was already asking before. We really had a long discussion within our group if we should go for a parameter inference, including an error model on the input, or just doing this sensitivity analysis where we compare really the input and the output. We went for the sensitivity analysis because we wanted to avoid the overfitting of the model, and we didn't want to calibrate the model on each scenario because we didn't have that much data, so we would additionally overfit our model, and we couldn't anymore compare the errors because they came from different sources in the end. Another thing we could do is really put the multiplicative error model on the input, but there you also have to do additional assumptions and including other deficits. So the exploration of this CML data can be intensified. We haven't fully explored the data set yet. What we want to do is also use the measured flow because we have this recording, and we want to try to find explanations or explanative variables which can explain the difference between the simulated flow and the measured flow for each scenario. We're thinking about looking at the duration of an event, the total volume of event, the time to peak, also the average flow, dry days before the event, and also coefficient of variation within the flow rate. So for concluding, the rain gauge information provides still the reference measurement to go for if we do a quick or an applied urban rainfall runoff study. If you have microwave links data available, you should include it because it gives you especially a better spatial resolution. And there's a lot more you can do regarding exploring these real measurements of microwave links networks. I want to thank the team that was working on this collecting of the data and also doing a lot of analysis beforehand, especially to Tobias Doppler, who worked in the field. Special thanks also to Orange, Salt, former Orange, for providing the microwave link data, which is quite exceptional for this time in Switzerland, and also for the funding by the Swiss National Science Foundation. With that, I want to stop and thank you for your attention. Yes, because we have a high density of rain gauges in these small catchments, so we believe that it's still the best way to go. Yeah?
If we are using Howling or shorter cascade?
The original data for the radar, we're using 2.5 minute data. For the microwave links, it's around 3 minute time resolution. And for the rain gauges, there were 1 minute measurements. So we interpolated to 1 minute time steps in the end. Really roughly.
And have you also checked how the model performs when you used only this one single rain gauge which you used for adjusting? If it's like if there is a improvement in using combined information from rain gauge and links?
You mean using the information of more than one rain gauge to adjust the microwave links?
No, I mean that you said that you used one rain gauge to adjust microwave links.
Yes.
And if you used also only this one rain gauge to model the runoff?
We also did that. It performed worse than the combined rain gauge situation. Yeah.
Remember well that the size of the catchment was 1 square kilometer.
1 by 3 kilometers.
Yeah, and you had five rain gauges there. What was the variability among the values? If you look at the variability, because it's really dense.
It's really dense, but still, yeah. We were also surprised that you can catch this variability within this small catchment with these rain gauges. That's also a reason why we did this preliminary analysis and also skipped the one rain gauge from the wastewater treatment plant because it had even a higher offset to the other ones.
You
You mentioned the adjustment of the microwave data. Was the data that was used for the adjustment fully independent in terms of weather and location, etc., or was it somehow dependent?
The microwave links to the rain gauge we are
When you do the
adjusting
adjustment, you say you do an adjustment of the microwave link data to correct for the bias. Now, if the data that you use for this adjustment is the same data that you then use for the verification, there is some...
Yeah, there's some overlap there.
Yeah.
We only used one rain gauge, not the full picture, like using all the rain gauges, interpolating them, but still there's a heavy overlap. If you would have more data, you would have to divide it into calibration phase and validation phase. Yeah.
Okay. Thank you.
Reducing bias and making